Hello friends, now we are discussing randomized algorithms. Deterministic algorithm. Regular algorithms follow simple steps that have predefined set of inputs and are required in output and follow suggested steps. The figure shows graphically input, algorithm and output. Deterministic algorithm, the output or the running time are functions of the input. The solution produced by the algorithms is correct and the number of computational steps is same for different run of the algorithm for that problem with the same input. Problems in deterministic algorithms. Give a computational problem. It may be difficult to formulate an algorithm with good running time. The explosion of running time of an algorithm for that the problem with the number of inputs. Randomized algorithm. A randomized algorithm uses a random number at least once during the computation to make a decision. Example, in quicksort, using a random number to choose the pivot element. Graphically run input algorithm, output randomized number. Randomized algorithms also, in addition to input, the algorithm uses a source of pseudo random numbers. During execution, it takes random choices depending on those random numbers. The output can vary if the algorithm is run multiple times on the same input. Randomized algorithms are not the probabilistic analysis of expected running time of a deterministic algorithm where the inputs are assumed to come from a probability distribution. The objective is to compute the expected running time of the algorithm. Classification of randomized algorithms. Randomized algorithms are classified into categories. Las Vegas, first one, Las Vegas. These algorithms always produce correct or optimum result. Time complexity of these algorithms is based on a random value and time complexity is evaluated as expected value. Example, randomized quicksort always sort an input array and expected worst case time complexity of quicksort is on O bracket in log n. The second one, classification of randomized algorithms. Monte Carlo produce correct or optimum result with the some probability. These algorithms are deterministic running time and it is generally easier to find out worst case time and complexity. Example, implementation of Carriage's algorithm. Monte Carlo finds first with probability 1 minus 1 by 2 into k. Time complexity of Monte Carlo is OK, which is deterministic. A Monte Carlo algorithms for a decision problem has two subtypes, one side error, two side error. Randomized algorithms. The Las Vegas algorithm always find an index of 1, but the complexity is determined as expected value. The expected number of trials before success is 2. Therefore, expected time complexity is or 1. Randomized algorithms advantages. The algorithms is usually simple and easy to implement. Second one, the algorithms is fast with very high probability and it produces optimum output with very high probability. Disadvantages. There is a finite probability of getting incorrect answer. Analysis of running time or probability of getting a correct answer is usually difficult. Getting truly random number is impossible. One needs to depends on pseudo number, so the result highly depends on the quality of random variable. Applications, load balancing, counting, and enumeration, parallel and distributed computing, graph algorithm, mathematical programming. Thank you.